In the last video, we discussed about what is harmonics, what are the types of harmonics, and what are the causes and effects of harmonics. Today, we will understand how to eliminate these harmonics if they are present in the system. So, the first type of harmonic filter or harmonic correction method is the passive harmonic filter. Now, what does this passive harmonic filter do is basically it blocks high frequency waveforms. So like last time we saw that harmonic frequencies are multiples of the fundamental frequency. So like third harmonics is 150 hertz, then fifth harmonics is 250 hertz, and so on. So it will block these kind of high frequency waveforms which are passing through the passive filter. So how does it work is, so basically if you identify that one particular load is generating a lot of harmonics and you don't want that harmonics to enter your main electrical distribution and affect the other loads as well. So what you can do is you can install a passive filter in between the distribution panel and the load. What this will do is the harmonics that is being generated by the load, it will not let that harmonics pass to the distribution system or the other equipments which are connected to the distribution panel. So that means in passive filter what we are doing is we are just blocking the harmonics. The harmonics is not removed but it is blocked so that it doesn't enter into the other equipments. The next thing is, the next option to eliminate the harmonics is a active filter, which is also termed as AHF or active harmonic filter. So what does this AHF do is, I have a distribution panel, I have a load, the AHF is connected in parallel to the distribution panel and it continuously senses what kind of harmonics are the loads creating and entering the distribution panel. So if you see on the right hand side, for example, if this is third harmonics and the waveform of the harmonics is like this, so what the AHF will do is it will sense what is the rating and what is the frequency of the harmonics and it will inject an equal and opposite waveform into the electrical distribution so that this and this is cancelled out. It will inject an equal and opposite waveform. So this harmonics is cancelled out and the system has clean waveform. So that is basically the function of AHF. Like we saw in passive filters, it was just blocking the harmonics, but in case of active filter, it is completely removing the harmonics so that the loads and the equipments are not affected. Then the third option is detuned reactors. Now, when do we need detuned reactors in our electrical system? So for example, if you have a electrical panel and there is load connected to that panel which is generating harmonics, but the harmonics is very less, it is around 6% or 7%. Sometimes it so happens because of resonance effect, the harmonics enter the capacitors and the capacitors in turn amplify those harmonics. So the harmonics which is around 6-7%, they directly go to say for example 20% or 25%. So to avoid this, we have to use detuned reactors in the capacitor panels. Some of you may also have seen some transformer like equipments installed in your capacitor panels. So they are not transformers, they are basically detuned reactors. What does this detuned reactor do is, so this is my distribution panel, this is my load. Okay, now what happens is when the load is generating the harmonics, this detuned reactor will block the high frequency. Like we saw in passive filters, it will do the same job. It will block the high frequencies and it will not let it enter the capacitors. So if this is 6% and it is not letting it enter into the capacitor, this will remain 6% and it will not amplify the harmonics. And if this detuned reactor is not present, what we'll do is the 6% will enter the capacitor and it will create an amplification. So this is where we require a detuned reactor. So we have looked at three solutions for removing these harmonics. First was passive filters, second was active filters, and third was detuned reactors. These three techniques are generally used to eliminate, block or remove the harmonics from the electrical system. Thanks for watching us.